KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we start with the 28th problem. Okay, right. So first to see this problem, then afterwards we will go one by one. So in this problem number 28, in photoelectric emission, process from a metal in photoelectric emission process from a metal of work function 1.8 electron volt here, the kinetic energy of most energetic electrons is 0.5 electron volt. Right. The corresponding stopping potential is dash. The corresponding stopping potential is dash. Okay, that he is asking. Right. So once again I will repeat the problem. You please be concentrate and try to identify the situation in the problem along with numerical values. For example, here they have given work function. So you know that work function generally we are using phi naught or W naught. Okay, right, phi naught. Which is phi naught is equal to 1.8 electron volt. Similarly, he has given that is what kinetic energy of most energetic electrons, that is what 0.5 electron volt. So that kinetic energy is 0.5 electron volt, right? So like that you have to get an idea, right? And then he is asking stopping potential. Stopping potential means generally Vs or V naught. The notation what we are using to represent stopping potential is either Vs or V naught. Okay, right. So like that we have to think. So in photoelectric emission, right? What is photoelectric emission? So what is photoelectric emission? When a metallic surface, right? I'll say from starting onwards. When a metallic surface exposed to the electromagnetic radiation, that is a form of energy, that is invisible form of energy, that is light, then emission of electrons takes place. Emission of electrons takes place from that metallic surface. So this phenomena is called as photoelectric effect or photoelectric emission. But I am not sure that whenever the light incident, immediately the electrons emission will take place, because there are so many factors. What is the energy of the incident radiation? What is the frequency of the incident radiation? And what is the wavelength of the incident radiation? What is the nature of the metallic surface, right? So these are all so many factors. But generally photoelectric emission means when a metallic surface is going to expose to the electromagnetic radiation, that is invisible form of energy or light. Okay, then emission of electrons takes place, right? So this is what we are calling it as photoelectric emission. Photoelectric emission. Okay, right. And here K maximum is equal to E into Vs. This relation we know. Maximum kinetic energy is equal to E into Vs. Okay, right. So they have given kinetic energy, maximum kinetic energy, that is what 0.5 electron volt. 0.5 electron volt. Okay. So when it is 0.5 electron volt, and this K maximum we have to replace with this numerical value what they have given, that is 0.5 electron volt is equal to E into Vs. Okay, right. So these two will get cancelled, E will get cancelled. Then finally you can say that Vs is equal to 0.5. Vs is equal to 0.5 volt. 0.5 volt. That is what stopping potential. That is what he is asking. See this problem. The corresponding stopping potential is Vs is equal to 0.5 volt, right? So a simple problem, right? That's why we should not confuse. So whenever they have given, one thing here, a small logic I will tell you. Here they have given metal of work function 1.8 electron volt. Work function 1.8 electron volt, right? If you observe carefully, this we didn't use. This we didn't use in this problem, right? So you try to think of yourself, why we didn't use this one, right? And they have given kinetic energy of the most energetic electrons, that is approximately, most energetic electrons is our consideration while solving this problem, not all the electrons, okay? So when they have given kinetic energy, that is as a 0.5 electron volt, no need to bother about work function. So directly, because of having this relation, right? Very well, that is what kinetic energy maximum or Ke maximum or sometimes K maximum is equal to E into Vs. Okay, that's why already they have given kinetic energy, that is 0.5 electron volt. Simple, that is equal to E into Vs. Then Vs is equal to 0.5 volt. Okay, right. Next problem, that is 29th problem. The threshold frequency for a photosensitive metal, the threshold frequency for a photosensitive metal is 3.3 into 10 to the power of 14 Hz. 3.3 into 10 to the power of 14 Hz. Okay, right. Full stop. If light of frequency 8.2 into 10 to the power of 14 Hz, 8.2 into 10 to the power of 14 Hz is incident on this metal, the cutoff voltage for the photoelectron emission is nearly, right? Cutoff voltage means here we have to find, that is what stopping potential, right? So which cut off the current, which cut off the photo current. That's why he is calling like cutoff voltage. But anyhow, have to keep in mind cutoff voltage means it is nothing but stopping potential. Okay, right. In this problem, the threshold frequency for a photosensitive metal is 3.3 into 10 to the power of 14 Hz. Okay, right. If light of frequency, so it is a frequency of incident light, that is what generally nu. So which is what nu, right? So that is here, that is 8.2 into 10 to the power of 14 Hz is incident on this metal. The cutoff voltage for the photoelectron emission is nearly, okay, right. Here first of all, we have to write and we have to know the given things. For example, in this problem, if you see here, this is what nu naught. This is what nu naught, and this is what nu. This is what nu, and Vs or V naught is equal to question mark. That we have to calculate. If possible, you write, no problem. Okay, and H is the Planck's constant. That is the constant. That is what 6.63 into 10 to the power of minus 34 joule second. Okay, right. And okay, these are all you can write, no problem. So like putting like a given and write down, you can write all the things. That is what the nu is equal to 8.2 into 10 to the power of 14 Hz, and nu naught is equal to 3.3 into 10 to the power of 14 Hz, and V naught is equal to question mark. Like that we can write. Next, according to Einstein's photoelectric equation, you know that EVS is equal, actually EVS is In place of kinetic energy we are writing kinetic energy is equal to h nu minus h nu naught. H nu minus h nu naught. Okay. So here in place of kinetic energy we have written EVS is equal to h nu minus h nu naught. Okay. Vs is equal to so what is Vs? Have to take this E to this side, h by E into nu minus h by E into nu naught. This is what stopping potential or Vs. Okay. Substituting the given values. So we have to substitute. So whatever the values they have given here, that we have to substitute. Then Vs is equal to, right, that is what 6.63 into 10 to the power of minus 34 by, observe here mathematically, you can take this as common, that is what h by E you can take as common, right, because here also h by E, here also h by E, h by E into nu minus nu naught. So 6.63 into 10 to the power of minus 34 divided by 1.6 into 10 to the power of minus 19, nu minus nu naught. So nu is 8.2 into 10 to the power of 14, that is what frequency of incident light, minus that is what the nu naught threshold frequency 3.3 into 10 to the power of 14. So do this mathematical process, then finally you will get it as, okay, it is what 10 to the power of 14 and right, and it is 8.2 and it is 3.3, and do this process, you complete this process, mathematical process, then you will get it as 2 volt. So stopping potential is 2 volts. Okay, right. Next problem, see here, that is what problem number 30. Monochromatic radiation emitted when electron on hydrogen atom, jumps from first excited state to the ground state, right, first excited state to the ground state. Okay, first excited state to the ground state irradiates a photosensitive metal, okay, or material, whatever it may be. You know, full stop, the stopping potential is measured to be 3.57 volt, full stop. The threshold frequency of the material is, okay, right. Once again, try to understand the situation given in the problem. Monochromatic radiation, you know very well, monochromatic means having single wave like red, blue, green, like that, emitted when an electron on hydrogen atom jumps from first excited state to the ground state, irradiates a photosensitive material, right, okay, right, full stop. The stopping potential is measured to be 3.57 volt, full stop. The threshold frequency of the material is, okay, right. You know, generally, okay, after completion of this problem, after completion of understanding this problem, you know, if you go towards the numerical or physical quantities, what they have given means stopping potential given, that is what phi naught, that is 3.57, right, sorry, stopping potential means Vs, Vs or V naught, okay, that is they have given as 3.57, right, it's okay, that is what Vs or V naught, okay. But asking to find threshold frequency means actually nu naught, okay. Generally, you know that phi naught is equal to nu naught into h or h nu naught, phi naught E is equal to h nu, phi naught is equal to h nu naught. So to calculate threshold frequency, we need work function. Planck's constant is a constant value, that's we know, right, okay. We need work function. So how to calculate work function? Again, Einstein's photoelectric equation, that is what phi naught is equal to h nu minus k maximum, h nu minus k maximum, right? And here they have given, that is what stopping potential, that is what Vs, and you know that Ke maximum is equal to E into Vs, E into Vs, that is 3.57 electron volt, okay, right? But we also need h nu to calculate, that is what work function, so that they can calculate threshold frequency, okay, right? So how to find out this h nu? Again you have to go to the, that is what formula to calculate energy of the orbit, I mean energy of the emitted photon when electron jumps from first excited to the ground state, okay, right? After that, you know, this formula h nu is equal to E2 minus E1, that is equal to minus 3.4 electron volt minus of minus 13.6 electron volt, it will be 10.2 electron volt, okay, right? So why I am coming from bottom means, in this way you have to think, because it is not a board level problem, no, it is Neet problem. So we have very short of time to solve this problem. That's why, you know, just after completion of understanding the problem, you just take a step by step as much as fast, okay, to save the time, that's it. So you know the formula to calculate, that is what energy when the electron is revolving in that particular orbit. The formula is, you know, for hydrogen atom, En is equal to minus 13.6 by n square electron volt, okay, right? So minus 13.6 electron volt, okay, right? Minus 13.6 by n square electron volt, ma. For ground state, n is equal to 1, no, right? That is what E1 is equal to minus 13.6 by 1 square, that is equal to minus 13.6 electron volt. Next, E2 is equal to minus 13.6 by 2 square, same formula. So here minus 13.6 by 4, that is what minus 3.4 electron volt, minus 3.4 electron volt, this is what E2. And we know E1 and we know E2. In board's postulates also you got it, right? E is equal to E2 minus E1. So here E means h nu. So you can say h nu is equal to E2 minus E1. So we have E1 and we have, we have E2 and we have E1. So E2 minus E1 means we will get it as h nu 10.2 electron volt, just substituting this value in place of E2 and in place of E1. So the energy of the emitted photon, when an electron jumps from first excited state to ground state is, the energy of the emitted photon when an electron jumps from first excited state to the ground state is, okay, h nu is equal to E2 minus E1, that is equal to, so we had that value 10.2 electron volts from mathematical calculation, right? By having the values of E1 and E2, if you write here and if you do that subtraction, then we will get it as 10.2 electron volt, okay, right? Next, maximum kinetic energy, that is what you can write, K maximum is equal to E into Vs, this relation we know, that is equal to E into Vs value is 3.57 V, that is equal to 3.57 electron volt, 3.57 electron volt, okay, right? Next, according to Einstein's photoelectric equation, we can write, right? You just think of yourself, when I am saying, when I am explaining, you just think of the possibilities whether it is correct or not, okay? So here, you know that formula, that is E is equal to phi naught plus Ke maximum. From that only we are writing phi naught is equal to h nu minus K maximum, right? H nu already therimu, that is what 10.2 electron volt minus, which is K maximum is 3.57 electron volt, right? So when you are going to subtract this value from here, 10.2 electron volt minus 3.57 electron volt, that is equal to 6.63 electron volt, right? Now threshold frequency nu naught is equal to phi naught by h, that is equal to This value we have to write in joules because Planck's constant we are taking in SI unit, that is what, joule second. That's why this value must be in SI unit, that is what, joules. So that 6.63 into 1.6 into 10 to the power of minus 19 joules, right. So complete that mathematical process, division, then you will get it as 1.6 into 10 to the power of 15, 1.6 into 10 to the power of 15 H, okay, right. Next problem, that is what, problem number 31. Which is the incorrect statement of the following? So they have given 4 statements. So we have to read the 4 statements and we have to identify the incorrect statement. Okay, see here. Photon is a particle with 0 rest mass. Photon is a particle with 0 momentum. Photons travel with velocity of light in vacuum. Photons even feel the pull of gravity. Even feel the pull of gravity, right? He is asking incorrect statement, not correct statement. So there are 4 statements. Out of these 4, 3 statements are correct. 3 statements are correct. Only 1 statement is wrong, right? So that you have to pick out. So regarding the nature of photons, you know, when light is satisfying the photoelectric effect, right? According to Einstein's, it is the light is a photon picture, right? So light energy, light ray consists of photons. Photons are like small energy pockets. So here, regarding the nature of photons, regarding the nature of light, mostly regarding the nature of photons, right? He has given 4 sentences, okay, 4 statements. Out of these 4 statements, only 1 statement is wrong. That statement you have to pick out, okay? So that statement is here, you know, okay, first you read the 4 statements, then you identify yourself, right? Then you just cross check with that information what I am saying, okay? So here it will be first one. So first one is the incorrect statement, okay? That is, photon is a particle with 0 rest mass, right? And remaining 3 statements are correct, okay? Next problem, see here, that is problem number 32. For photoelectric emission from a certain metal, the cutoff frequency is nu. So that is what cutoff frequency, you know, threshold frequency. Actually threshold frequency we are using a letter nu naught. But here according to this statement, this information, nu naught is equal to nu. Next, if radiation of frequency 2 nu impinges on the metal plate. So here it is what the radiation of frequency 2 nu means, you know, according to our, that is what when we were in a discussion about photoelectric effect, radiation of frequency is nu actually. So in place of nu we have to take 2 nu impinges on the metal plate, incident on the metal plate, comma, the maximum possible velocity of the emitted electron will be, the maximum possible velocity of the emitted electron will be. So m is the electron mass, m is the electron mass, okay, will be dash, right? So here he didn't give any numerical value, but finally he is asking like a formula. For this situation, he is asking what is the formula to calculate maximum velocity of the electron, maximum possible velocity of the emitted electron, okay, right? See here, you know, according to Einstein's photoelectric equation, Ke maximum is equal to h nu minus h nu naught, okay. You know that K is equal to half mv square formula. So half m into v maximum square, half m into v maximum square is equal to h into, in place of nu we have to write 2 nu, I already told you, just now I told you. And in place of nu naught we have to write nu, see here. Right, that is the what logic, right? We have to, we should not confuse here. Suppose if you are taking reverse means you won't get the correct answer, right? So simply he is confusing us to get the clarity. So whether we confused or not, okay? So here according to the given information, nu naught is equal to nu and nu is equal to 2 nu. So substitute here and then rest of the process is mathematical, right? So just here you take this 2 to that side. You know, it is 2 h nu minus h nu means h nu will come, and you take this 2 to that side, 2 h nu, and if you take this m to that side, 2 h nu by m. So V maximum square is equal to 2 h nu by m. 2 h nu by m. Okay, right. And he is asking maximum possible velocity, no, not square of the velocity. He is asking velocity. So V maximum is equal to square root of 2 h nu by m. Square root of 2 h nu by m. Okay, right. Next problem. That is what 33 problem. See here. When the energy of the incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from a metal surface increased from 0.5 electron volt to the 0.8 electron volt, right? So is see here when the energy of the incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from a metal surface increased from 0.5 electron volt to the 0.8 electron volt. Okay, full stop. The work function of the metal is so it is like what is that this problem containing or consisting the relation also. Here we have to know the relation between energy of the incident radiation and kinetic energy of the photoelectrons emitted. Right? That relation also we have to keep in mind. Otherwise we can't solve the problem. Okay, right. See here. According to Einstein's photoelectric equation, that is what Ke is equal to h nu minus phi naught. Okay. So this is like a formula, that's we know. Now you substitute these values here. That is what first it is what 0.5 electron volt is equal to h nu minus phi naught. That is like equation number 1. When we are writing this expression, the initial energy of the incident radiation is h nu. But according to the question, in the second case, it is increased by 20%. So 20% means h nu plus 20 by 100 h nu. 20 by 100 h nu. So 20 by 100 means 1 by 5 no, 0.2 no. So already h nu plus increased 20%. So h nu plus 0.2 h nu. So in the second case it will become as 1.2 h nu. That is the logic behind giving this statement or information. So 0.8 electron volt is equal to 1.2 h nu minus phi naught. Okay, this is like equation number 2. So we got two equations. One is 0.5 electron volt is equal to h nu minus phi naught. Another one is second equation, that is 0.8 electron volt is equal to 1.2 h nu minus phi naught. That is the second equation. Okay, right. So by solving these two equations, you can get it. See that phi naught as 1.0 electron volt. That is what 1 electron volt. Okay. So that is what he is asking, work function of the metal. As per question, that is phi naught is equal to 1 electron volt. Okay, anyhow 1.0 means 1 electron volt. Okay, right. So in this class we discussed the problems, numericals, nature of light from 28 to 33. Okay, right. So in our next class we will start with 34th problem. Thank you.